please put your pencil down. This lesson is about multiplying rational expressions such as these. But again, please put your pencil or pen down. Watch and learn how to do the problems, but then go back and try to do these same problems by yourself. If you sort of copy along with me as I'm doing the problems, you're not really going to learn how to do it. You're learning how to copy, but I think you already knew how to do that. Also, I apologize in advance. I'm losing my voice, so I can barely talk. So my voice is going to be a little bit more monotone than it usually is. So try to stay awake. Problem number 1. Well, notice that the ends are going to cancel each other out. You know what? There's something I'm taking for granted that you may or may not know. When you have two fractions that are being multiplied together like this, you can treat it like one big happy fraction. Okay? It's just as good as if this were all within one fraction. Okay, so if I have this n in the numerator and another one in the denominator, then those are simply going to cancel each other out. Alright, so what I have now is 59 times 80 over 99 times 33. Before I actually multiply these together, it would be easier to look now and see if there's anything that will divide into a numerator and a denominator. And it doesn't matter whether I'm just looking at the 59 and the 99, or the 59 and the 33, or the 80 and the 99. As long as I'm doing a numerator and denominator, it's fine. However, 59 is a prime number, so nothing's going to divide into 59 other than 1 and 59. So let's see, what divides into 80? Some things that divide into 80 are, other than 1 and 80. This is going to be divisible by 2. It'll be divisible by 4, divisible by 8, divisible by 10. Alright, at a glance you can see that 80 is divisible by all of these things. Now, do any of these things divide evenly into 99? No. Okay, or it probably would have been quicker to look at it the other way around. For example, if I look at 99, 99 is divisible by 3 and 9. But neither one of those go evenly into 80. Okay, oh, and 11. Alright, same thing with the 33. 33 is divisible by 3 and 11. But 80 is not divisible by 3 or 11. So there's no numerator and denominator that are both divisible by the same thing. So that means there's no reducing that I can do. So all I can really do is multiply these together. So 59 times 80 is, let's see, 59 times 80, that's 4,720. Okay, and 99 times 33 is 3,267. So that will be the answer to problem number 1. Except let's not forget to state the restrictions. In this case, n cannot equal 0, because that would cause a 0 denominator right there. So that's part of the answer. Okay, problem number 3. Again, you can treat this like one fraction. So, numerator, denominator. These ends will cancel each other out. So, I still have this n will be left. So, I will reduce whatever I can, but I will have an n left at the end. Okay, so whatever else happens, I'm going to have an n in the denominator, so I might as well go ahead and show that. So let's talk about the rest of this. I was trying to avoid it, but I don't see any way around it. Let's talk about prime factorization. It's a matter of taking each one of these numbers and breaking them down to a product of prime numbers. For example, if I look at 34, okay, do you remember factor trees? 34 is even, so I know it's divisible by 2, and 2 is a prime number. 34 is 2 times 17, and 17 is also a prime number. Okay, so I'm going to circle these because this is the end of the line for 34. So 34 can be written as 2 times 17. Okay, that's the prime factorization. Let's do that to all of these numbers. Okay, so I've now replaced 34 with 2 times 17. And how about 93? Okay, let's look at 93. 93 is clearly divisible by 3, so let's start with that. Alright, it's going to be 3 times 31. Okay, and both of these are prime numbers. Okay, so this is the prime factorization for 93. So let's replace 93 with 3 times 31. Alright, 21 we can do in our heads. Alright, because we know that 21 is 3 times 7. 51. At a glance, I know that 51 is divisible by 3 because 5 plus 1 is 6, and 6 is divisible by 3. So 51 divided by 3 is 17. That means 3 times 17 is 51. Okay, so that'll be the prime factorization for 51 will be 3 times 17. Okay, now the reason for doing this is because now it's much easier to see what needs to be canceled out. So any factor that's the same in the numerator and the denominator can cancel. So for example, 3, this 3 will cancel out this 3, alright, numerator, denominator. Notice it can't cancel out this 3, you know, it's 1 to 1 cancellation. Is there anything else I can cancel? Yeah, well, I've got this 17 right here, so this 17 is going to cancel out this 17. So if I didn't do this prime factorization thing, I would not have noticed that I could cancel out the 17s. Alright, so now I've got a 31 and a 2 and a 7 and a 3. There's nothing else that I can cancel out. So now I will go ahead and multiply. Okay, so 31 times 2, that's 62. So I'll have a 62 in the numerator. And of course, 7 times 3 is 21. So I'll have a 21. And that's it. So this will be the answer to number 3. Alright, so if you can factor in your head, that's great. Otherwise, do a factor tree. But for problems like this, the prime factorization is your friend. Except let us not forget to state the restrictions. In this case, n cannot equal 0. That is part of the answer because of you can't have a 0 denominator. Alright, let's take a look at number 5. N is the only variable, so whatever else happens, again, I'm going to have n on the denominator just sitting there. Now, let's do the prime factorization for everything else. Some of them we can do in our head, like 25 is going to be 5 times 5. That's it. Those are prime numbers. Okay, 45 takes one extra little step. Alright, 45 is 5 times 9. Alright, 5 is a prime number. But 9 can be further factored as 3 times 3. So the prime factorization for 45 is 3 times 3 times 5. Okay, so I will replace 45 with 3 times 3 times 5. Or I guess I could have done 3 squared times 5. Anyway, let's look at the 96. Alright, 96 is clearly divisible by 3. Alright, 3 times 32. Yeah. 3 is a prime number, but 32 is even, so I know that that will factor more. That'll be 2 times 16. Alright, 2 is another prime number. 16 is not. 16 is even. That'll be 2 times 8. Alright, 8 is 2 times 4. And 4 is 2 times 2. Okay, now that's a lot of 2's. So I think I will break down and write this as, see, 1, 2, 3, 4, 5 2's. This is 2 to the 5th power. So I've got 3 times 2 to the 5th power. Okay, let's do it that way. And let me be consistent if I'm going to do that. So 5 times 5, I could write that as 5 squared. Alright, and like I said, 3 times 3 times 5, I can write this as 3 squared. Okay, prime factorization. How about 38? 38 is even. Alright, so that's going to be 2 times what? 19. And right away both of those are prime numbers, so there you go, prime factorization. Okay, so that's 2 times 19. So now we have the prime factorization, so it's time to look for factors that are the same in the numerator and the denominator. So for example, I see that we have 3's. Okay, I've got a 3 up here and I've got 2 3's down here. Alright, so I think I'll do this in like phases. Okay, so this 3 is going to be canceled out, and here I have 2 3's down here. So this 3 is going to cancel out one of these 3's, and that's just going to leave behind just the 1 3 left. Okay, so that's it for 3's. What about 2's? Alright, I've got 5 2's in the numerator, 2 to the 5th power. Alright, down here I've just got the 1 2. So this 2 is going to cancel out one of these 2's. Okay, and so that'll leave 2 to the 4th power. Okay, what else do we have? Now let's talk about the 5's. I have 2 5's up here and 1 down here. So this 5 is going to cancel out one of these 5's. Okay, and just leave 5. So I've got 2 to the 4th power times 5. You know what, maybe I'll just write this down temporarily. So in the numerator I have 2 to the 4th power times 5. Okay, that's it. And in the denominator I have 19 times 3. Okay, and of course that n is still sitting there. Okay, so 2 to the 4th power times 5. That's 80. Alright, so in the numerator I have 80. And then 3 times 19 is 57. So that'll be 57n. So this will be the answer to number 5. Except let us not forget to state the restriction. N cannot equal 0. This won't always be the restriction, but so far it has been. because you can't let the denominator at any point be 0. And if n was 0, that would make this denominator 0. So this is part of the answer. Okay, let's go ahead and do one more. Now, right away, I see that we have r plus 2 and another factor of r plus 2. One in the numerator and one in the denominator. So treat this like it's one fraction. Okay, whenever you have multiplication, treat it like it's one big fraction. So these this factor of r plus 2 will cancel out, so they're gone. Alright, this r is not going anywhere. But see this 6? Alright, I have a 6 in the numerator and a 6 in the denominator. So I can definitely cancel that out. Okay, and then I have 4 and 20. Okay, 4 goes into itself once, but 4 goes into 20 5 times. So I can make that happen. Alright, so that's going to leave us with, so nothing is left in the numerator except for r. You know, 1r, but that's just r. In the denominator, everything is gone except for 5. Alright, so number 7 simplifies down to just r over 5. But not so fast. Restrictions. And in this case, it won't simply be r cannot equal 0. You have to look at the denominator of the original problem, or any step along the way, and look for variables, variable factors. So I have this r plus 2. That cannot equal 0. Very important. So r plus 2 cannot equal 0. Subtracting 2 from both sides, that gives me r cannot equal negative 2. So that's the restriction for number 7. R cannot equal negative 2. Okay, that was pretty quick. Let's go on to number 9. Okay, now I see this factor of p minus 3 in the numerator and the denominator. So p minus 3, those will cancel out, so that's gone. I also see a factor of 2. Alright, this 2 is going to cancel out this 2. Okay, so really that leaves me, the answer is right here. Okay, so I'm just going to recopy that. So the answer is going to be p plus 6 over 4. We got to include the restrictions though. So we canceled out a variable right here. Let's not forget that this factor cannot equal 0. So p minus 3 cannot equal 0. Adding 3 to both sides tells me that p cannot equal 3. Okay, so that's our restriction. P cannot equal 3. Alright, because if it did, I'd have 3 minus 3. That would make 0. I've got a 0 denominator. That's a big no-no. Alright, let's keep going. Number 11. I see, remember, treat this as one fraction. So as long as you have something in the numerator and the denominator, it's gone. So I have the m plus 1 in the numerator and denominator, so they cancel out. I've got the 8 in the numerator and denominator, so they're gone. And that's it. Nothing divides into 7 and 9, so they stay. So the final answer is 9 over 7m. Okay, now here we have two variables in the denominator. All right, neither one of these factors can equal 0. So 7m cannot equal 0, and m plus 1 cannot equal 0. Really, I don't need to bother with the 7. Okay, I can treat the 7 and the m as two separate factors, and only the m is the problem. So m cannot equal 0, and m plus 1 cannot equal 0. Alright, of course, subtracting 1 from both sides, and we see that m cannot equal -1. So those are the two restrictions. M cannot equal 0, m cannot equal -1. Okay, how about number 13? Now, I see a GCF right here, so let's deal with that. Okay, when you have a GCF, you should go ahead and factor that out. So, with a GCF of 10, that would leave behind v plus 3. Okay, so I've now replaced 10v plus 30 with 10 times v plus 3. So with that in mind, the v plus 3 will cancel out with the 1 in the denominator. So far, that leaves me with this. 1 times 10 is 10. So in the numerator, I have 10. In the denominator, I have v plus 10. Can I cancel out these 10s? No. Alright, you can only cancel out things that are connected by multiplication. Okay, like down here, this was multiplication, so I could cancel it out. But you cannot cancel out something that is connected by addition or subtraction. So this is the final answer for number 13. Alright, let us not forget the restrictions though. Neither one of these factors can equal 0. So v plus 10 cannot equal 0, and v plus 3 cannot equal 0. So subtracting 10 from both sides and subtracting 3 from both sides gives me that v cannot equal -10, and v cannot equal -3. Alright, so this is part of the answer, so don't forget it. Alright, that brings me to the end of this page. So this would be a good time to stop the video. Alright, I will pick up with number 15 on the next video. So I'll see you then.